Okay, let's give you guys some more practice. So here I'm trying to heat up some water in this conic container here. So the equation for this line here is y equals 2x. Rotate it 360 along the y-axis. It will trace out a cone. Well, this is water here. So we are heating it. So at the moment the temperature here is 95 degrees Celsius. Up here is 71 degrees Celsius, and over here the equation is given by this, and the temperature down here is 58. Temperature up here is 23. If I were to pour the water into a new container, so this is our cone here, and this is this here. Okay, so if I were to pour the water into here, get a spoon and then mix it up, at what temperature will the water settle at? Okay, so assuming the spoon doesn't absorb any heat, assuming the container here doesn't absorb any heat, what temperature will the water settle at after me stirring it? Okay, so work it out. So press pause and have a go. Okay, so to do this, hang on. So to do this, remember we're trying to find out, in effect, we're trying to find out the average temperature. Okay, so it's really us. Hang on, it's really us. It's really us doing this. So we are trying to find the average temperature of the two mixed together. Okay, so we're going to combine the two. Well, the average temperature would be, well, first combine the temperature and the volume for this thing here. So this is our temperature here. Combine it with the volume. So this is our temperature here. So hang on. This cone here is this bit here. This thing here is this thing here. And then here we're dividing it by the total volume of the two. So this here is the volume of this, and this here is the total volume of this. Okay, so so this cone here is this bit here, and then this here is the temperature of the cone. So we need to set this up later. This bit here is the temperature from 95 to 71. To 71. And then pi r square is. So don't forget we're summing up all the disks. So the thickness of this disk here is dy. So this is dy here, and we need to know the radius of this thing here. Well, the radius of this thing here is really us looking at this. So remember, you're summing up all the disks, and then at this precise moment, at this precise value of y here, the radius will be y over 2. So this is our radius, and then when you pi r square it, it becomes pi y squared over 4. Okay, so that's the disk here, and then we've got to combine it with the temperature. So our next step is to set up the temperature for this. Okay, so don't forget our temperature is a smooth transition from 95 to 71. So we need to set up our temperature. So now let's look at this bit here. Okay, so hang on. So we are still looking at the cone. Later on we will look at this. Okay, but let's just look at the cone for the time being. So for the cone, for the cone here, remember our temperature is a smooth transition from 95 to 71. So we need to set up the temperature in such a way that, remember, we are summing up all the disks. So y is moving about. So as y is moving about here, let's just say y is currently here. Okay. So the thickness associated with this disk here is dy, which is this bit here. But we need to set up the temperature. The temperature, well, remember the temperature, y is moving about here. We need to set up the temperature in such a way that when y is 0, the temperature is 95. We need to set up the temperature in such a way that when y is 0, the temperature is at 95. Okay, and then we need to set up the temperature in such a way that when y is 4, then the temperature is 71, which is 71 here. So really, our temperature is really the equation of this line here. Our temperature is the equation of this line here. Well, this is a straight line. Y equals mx plus c. C in this case is 95. The gradient in this case would be 95 take away 71, which would be this, and then divided by the width here, which is from 0 to 4. Well, the temperature here is given by this. So now we can put this into here, okay? And don't forget, our radius is y over 2. Yeah, our radius is y over 2. Square it, that will give you y squared over 4. So from here, it would take us to here, okay? And then now for this we need to set up. So this is our aim for this one here. So remember, we're summing up all the disks. So we want to set up the temperature in such a way that when y is 0, the temperature is 58. So when y is 0, the temperature is 58. So we want it to cross right here, okay? And then we want to set it up in such a way that when y is 4, the temperature is 23. When y is 4, the temperature is 23. Okay, so really our temperature here is given by the equation of this straight line here. Well, the equation of this straight line here is given by this. So now we can put this into here. And for the radius, remember, we're summing up all the disks. So the radius at this precise moment is, well, looking at this here, the radius will be root y. So when you come to pi r square it, it's really pi, this thing here, put it into the r, so that would be square root of y, and then we've got to square it, so that will give you pi y. Okay, so that will then give you pi y. Okay, so that will then take you to here. Okay, that will then take you to here, and then remember, here we are combining the temperature with the volume for the cone. Okay, and here we are combining the temperature and the volume for this, and then down here we are combining the two volumes together. Okay, so from here that will then take you to here. Okay, and then blah blah blah. Just follow your normal routine. Solve this. So it's blah blah blah, and then blah blah blah, and then the mix. Well, so when you mix, so the overall, the average temperature will be given by this. So if you mix this with this, the temperature should settle at 51.6 degrees Celsius. Okay.